Welcome back to the deep dive. We're here to give you that essential distilled knowledge you need to stay ahead. You've brought the curiosity, we've got the sources. We're seeing this really fundamental shift happening in tech right now. Over the next, say, 5 years, AI isn't just going to be about experiments anymore. It's moving towards being core infrastructure.
That's absolutely right. And this whole series is mapping out the 10 key developments really driving that shift. We've already dug into foundation models.
Yeah.
Right, FS and self-supervised robotics, SSR, and AI-generated synthetic data platforms. They're all crucial building blocks.
Tools for the future, definitely.
But they kind of all hinge on one big technical breakthrough that we really need to talk about today.
Yeah, and that breakthrough tackles this core problem. Current AI, seems to be hitting a wall capability-wise. For AI to really handle complex stuff, nuanced decisions, multi-step reasoning, think law, medicine, finance, you can't just keep making the neural networks bigger and bigger.
Exactly. That approach, just scaling up, it's starting to show diminishing returns. Plus, you often end up with these black box systems.
But you don't know how it got the answer.
And that lack of logical reasoning, that's the real bottleneck we're hitting.
Which brings us neatly to today's focus, Neuro-symbolic Reasoning Engines, NSREs for short. This is number 4 on our list of key developments, and it feels like a necessary next step, an evolution. Okay, let's unpack this.
Well, the timeline itself is pretty revealing. It shows how fast the industry thinks this can move once the basics are sorted. Our sources suggest between 2025 and 2027, NSREs will mostly be in research labs.
Okay, so academia and some very specific commercial uses first.
Right, limited deployments. But then, once the foundational tools start to mature, things are expected to accelerate quickly.
So when are we talking enterprise level?
Full enterprise integration, meaning it becomes sort of standard operational tech. That's expected around 2028, maybe into 2029. So it's not some far-off sci-fi thing. It's really just around the corner.
Let's get into the architecture then. Neurosymbolic. It sounds complex, like combining 2 totally different ways of thinking about AI. How should we picture this working?
It's maybe helpful to think of it like a partnership. You've got, say, an intuitive pattern-spotting artist working with a very meticulous rule-following accountant.
Okay, I like that. Artist and accountant.
The neuro part, that's your deep neural network. That's the artist. It's brilliant at perception, seeing patterns in noisy data, understanding ambiguity, generating complex stuff from raw input.
Handles the fuzzy stuff.
Exactly. But then, that neural part feeds its findings into the symbolic layer. That's the accountant. This layer works with predefined rules, explicit logic, structured knowledge. Think traditional AI, good old-fashioned AI almost.
GOFAI.
Sort of, yeah. So the neural network gets the initial feel for the data, and the symbolic layer makes sure that understanding lines up with a logical framework. It imposes structure.
So the neural net figures out what it's looking at generally, and the symbolic part checks if it makes sense according to the rules.
Precisely. And when you fuse those two, you start getting capabilities that, frankly, today's large language models just can't reliably deliver. The sources mention things like probabilistic logic programs and something called differentiable theorem provers.
Okay. Differentiable theorem prover. That sounds heavy. What does that actually do for the AI in simple terms?
It's basically the ability to check its own homework. When the AI makes a complex decision, this differentiable theorem prover lets the system look back through its own logical steps and validate them against the rules it's supposed to follow. So it's not just spitting out a statistical best guess. It's providing a kind of proof or at least a traceable chain of reasoning it believes is highly probable.
So it can show its work.
Yes, exactly. And this enables those probabilistic logic programs. It means the AI can handle uncertainty, the probably true part, but still keep it within a formal logical structure. It can say, based on patterns, this seems likely, and here's the step-by-step logic that supports that.
Right, which leads straight to the big why. If deep learning models are already so powerful, why bother with engineering this, seemingly complicated hybrid? Why is explainability suddenly such a huge deal?
Because AI is moving from just suggesting things to actually making decisions, and you simply can't trust a system making high-stakes calls if you have no idea why it made that choice, it boils down to trust.
Makes sense.
So the value of NSRE is really 2 things, and they hit the biggest pain points in AI adoption right now. First, explainability, like you said, that solves a huge regulatory headache.
Because you can trace it back.
Yes. Since the output has to go through that symbolic logic layer, you can trace every decision back to the specific rules it used. For audits and regulated industries, that's absolutely essential, non-negotiable.
Okay, that's the compliance piece. What's the second part?
The second part, which I think is even more interesting, is handling genuinely complex decision-making. Pure neural nets are great at spotting patterns, generating text or images.
Yeah, amazing stuff.
But they notoriously struggle with multi-step sequential reasoning. They can kind of lose the plot, logically speaking.
Right, they might miss a crucial connection.
Exactly. NSRE aims to bridge that exact gap. The neural part can understand the nuances of, say, a complex legal contract, but then the symbolic layer can execute complex step-by-step logical operations on it, like cross-referencing specific clauses, spotting potential conflicts, applying known legal rules or statutes.
So it reads the contract and understands the legal framework around it.
Precisely. And the sources specifically call out legal contract analysis as a prime example. It needs both that deep perception and strict adherence to rules. NSRE is built for that.
Wow. Okay. That kind of capability, you can immediately see how it starts to reshape industries where the stakes are high. It injects that guaranteed transparency, that accountability.
Totally. You're not just crossing your fingers hoping the AI's statistical guess was right. You actually know the rules were applied. Yeah. And that boost in trust and accuracy, well, it's going to ripple through finance, obviously, where audit trails are critical. Healthcare, too. Think clinical pathways, safety protocols that must be followed logically, cybersecurity, which relies heavily on sequential logic, and robotics, where you need precise, rule-based actions in the real world.
I think the biggest win here might not just be better AI performance, but better collaboration between humans and AI.
That's a great point.
If the system can actually explain itself, show its logical steps, then people are going to be much more willing to trust it and integrate it into really critical workflows.
Absolutely. Imagine a doctor getting an AI diagnosis. If it just says condition X, that's one thing. But if it says condition X because of data points A, B, and C, interpreted through Clinical Rule 7.2, that totally changes the dynamic. It enhances the human's understanding. The AI stops being a mysterious black box and becomes more like a very logical colleague.
Let's circle back to that capability ceiling idea, because that really seems to be the core technical driver here, why NSRE became necessary in the first place. We've kind of been told for years, bigger models, better results.
Right.
But the sources are saying, hang on, just making these neural nets gigantic isn't cutting it anymore. We're hitting diminishing returns.
That's the reality check the field is grappling with, yeah. Just throwing more compute and more parameters at the problem, it's running into limits, the costs are ballooning, and you're not necessarily getting proportional gains in actual logical reasoning or reliability. Sometimes scaling just means you make the same mistakes, but much more expensively.
So if we can't just scale up vertically, just make the model bigger, how does NSRE fix this? Is it about scaling differently, horizontally, maybe?
That's a really good way to think about it. Neuro-symbolic approaches offer an alternative path to scaling. Instead of just brute forcing scale with raw power, you're trying to scale intelligence more efficiently. By combining the strengths of both approaches, the neural network's ability to generalize, and the symbolic system's precision and structure, you're building smarter, not just bigger.
And this isn't just theory. We're seeing this work in practice.
Oh, yeah. It's moving beyond theory. The sources point to specific frameworks that are showing this works. They can handle increasing complexity, larger data sets without falling over. Names like Dolphin, Embed2Sim, and CogSys are mentioned.
Okay.
These are examples proving that this hybrid model isn't just a nice idea. It can be engineered to work at scale.
So what are these frameworks doing differently? How are they managing that complexity without, grinding to a halt?
Well, they use clever techniques. Things like multi-agent systems where different parts specialize, and also retrieval augmented generation, or AGRE. That one's becoming really important.
Okay, yeah, AGRE comes up a lot lately. Can you unpack that a bit? What does it actually let the system do?
Sure. So ARAG helps with scalability and accuracy by letting the neuro-symbolic system pull in specific, relevant facts from an external knowledge base before it generates its output.
Like looking something up.
Exactly. Instead of trying to have all knowledge crammed inside the neural network itself, which is prone to hallucinations or making things up.
Right.
It can retrieve the precise definition, the specific rule, the latest data point it needs when it needs it. It's like giving the AI access to a reliable library or database during its reasoning process.
That makes the reasoning much more grounded in facts.
Way more grounded. And it helps manage the complexity because the core reasoning engine doesn't have to internally represent everything.
And that ability to pull in new information dynamically, that must be huge for businesses.
Yeah.
You don't have to do a massive, expensive retraining every time a regulation changes or you get new product specs.
Exactly. That agility is key. Being able to integrate new rules, new data, without a full model rebuild. That dramatically changes the cost-benefit equation for deploying sophisticated AI and makes it much more practical.
Okay, so if this NSRE approach seems like the logical next step, it offers better capabilities, more accountability, smarter scaling. What's the catch? Where are the roadblocks? Here's where it gets really interesting. What's stopping NSRE from just taking over everything right now?
Yeah, it's not all seamless yet. The main challenge right now is really about the maturity of the tools and the integration frameworks. The core ideas are solid, but actually getting these two very different types of systems, neural and symbolic, to work together smoothly, that's tricky.
So the plumbing isn't quite there yet.
That's a good way to put it. The frameworks for connecting them are often fragmented, maybe a bit clunky, sometimes custom built for each project.
Right, like trying to bolt together parts from different eras of technology?
Kind of, yeah. You're trying to get this sleek, modern neural network to talk efficiently with a more rigid logic-based system. Making that interface clean and standardized, that's a big engineering hurdle. It slows things down, makes systems potentially brittle.
Okay, tooling maturity. What else?
The other big one is a potential performance trade-off. Neural networks are built for speed, right? Massive parallel processing. But the symbolic layer often has to work more sequentially, carefully checking rules step by step. That logical checking can sometimes become a bottleneck, slowing the whole system down.
So the accountant part takes longer than the artist part.
It can, yeah. So there's a lot of research focused on how to speed up that symbolic reasoning without losing the logical rigor.
How are they tackling that? Making the logic fuzzy, too.
Not exactly fuzzy, but more flexible. They're working hard on what's called differentiable reasoning. The goal is basically to make the symbolic steps integrate more smoothly, more efficiently, with the way neural networks learn and process information.
So the neural network can kind of learn how to use the rules better.
That's the idea. Making the logic layer less rigid, more adaptable within the network's flow so it doesn't just act as a slow check at the end. It's about weaving the logic into the learning process itself.
Fascinating.
But look, the push to develop these hybrid systems, these NSREs, and the tools to build them, it's undeniable. It really feels like the necessary path forward if we want AI to reach its full potential. We need solutions that are more robust, more adaptable, and frankly, more trustworthy and scalable than what we can get just from making current models bigger.
So NSREs give you that pattern matching flexibility, seeing the big picture of the forest, but crucially add the accountability of structured logic, making sure each tree is accounted for and follows the rules. So what does this all mean? Well, we've laid out how just scaling up neural networks seems to be hitting a wall cost, explainability, complex reasoning. So the big takeaway for you might be to consider how profoundly this move away from just bigger is better, towards valuing the efficiency and accountability of hybrid architectures like NSREs, how that might just reshape the whole competitive landscape in AI over the next few years. The winners might not be the ones with the absolute biggest models, but the ones who master these smarter hybrid combinations. Think about what that means for innovation and strategy until our next deep dive.
Until next time, keep exploring, keep questioning, and keep diving deep. Thank you for listening to today's podcast. Please feel free to click on the link in the description below to discover more podcasts.